everybody, it's Michael Mathias, and I'm here to talk to you about the new era of our ecosystem, and specifically to share details of the blockchain that will power the growth of our ecosystem from this point forward. Now, the concept of blockchain everyone's familiar with, and we're all familiar with the promises that blockchain makes. It promises to be fast, transparent, trusted, immutable, frictionless, secure, distributed, and disintermediated. These are all great qualities. However, they don't always come out in the implementation of the technology. There's a tension between our aspirations for blockchain and the actual technology and what it delivers. In the industry, this has been commonly referred to as the blockchain trilemma. So not dilemma, but trilemma, because there's three areas of very high importance. The first is security. Of course, that is key. The second is scalability, and that has to do with performance and how the ability to grow the system itself. And the final piece is decentralization, that is seen to be very important, but inevitably falls out of this trilemma when blockchains are trying to solve the problems. It's just difficult, and some believe impossible, to have all three of these factors at once. You got to choose two, and typically it's security and scalability. So let's talk about how the blockchain trilemma relates to the power chain. And the good news here is that our next era of ecosystem has finally arrived. And the even better news is that this blockchain trilemma is finally solved and is incorporated into our new era. First, let's look in the past and talk a bit about our Powerchain 1.0 implementation. This was on the codebase of Graphene Toolkit, which is a very solid technology that BitShares and other blockchains are built on. Offered a lot of strengths in the realm of performance and scalability, very fast, high capacity, low cost transactions, and we had very solid tokenomics on that system. The weaknesses were in the lack of decentralization to the system. It caused for some weakness on the chain itself, the strength of the chain itself, because of that lack of decentralization. And that factor, played into issues with, I'm calling it security of the contracts. We didn't have contracts yet at that point, but what it refers to is the connections between the blockchain itself and supporting systems like the wallet system. So that was a problem in that implementation. There were, also the user community hadn't grown beyond a certain level, and then the developer community hadn't yet taken root. So those were some very clear weaknesses that led to the transition to Ethereum. So in September of 2020, we began our transition from the original blockchain to the Ethereum network. And this brought a number of strengths. First and foremost, the security of the chain, which is world-class in Ethereum. Also, an enormous user community. Ethereum has over 71 million wallets, and the largest developer community. So some great strengths, but there still are weaknesses. Its decentralization is not at the level that it could be. The security of the contracts, that's an area where the contracts, it was the innovator of smart contracts, Ethereum. And that's a great thing, but it comes with some of those pioneering problems. And the smart contracts on Ethereum are quite complex and are prone to some insecurity. And you hear about hacks of smart contracts quite a bit in the news. So that's a weakness. The tokenomics are not nearly as clear and straightforward as, say, Bitcoin, where everyone knows there's 21 million units. So it's a bit opaque on the tokenomics. But the real problem with Ethereum is in the realm of performance and scalability. And this is where, it really has faced quite a problem. The blocks themselves are not terribly slow. 15-second blocks, it's on the slower side, but it's certainly not 10 minutes like Bitcoin. The transaction per second is definitely very low, especially in the current age of these kind of third generation blockchains. So 15 transactions per second is why there is such congestion on the Ethereum network. And worst of all is the expense of transactions. Because there is so much congestion, transactions on average are just ridiculously expensive in comparison to virtually every other blockchain in the world. So this has been a problem, and it has affected us and stopped the momentum of our original bridge to Ethereum. How can we solve the trilemma and have security, scalability, and decentralization in one implementation? And how can we have this right away so we can start building out our ecosystem? Well, the way we can do this is through a blockchain called Algorand. As of this month, the majority of GRN and GOV tokens are on the Algorand network. And this delivers tremendous strengths to our ecosystem, starting with performance and scalability. This chain has very fast finality, 4.5-second blocks. It's got great capacity, generally running at 1,000 transactions per second, and has low-cost transactions, under a cent, a US cent. Its security is extremely good on both chain and on its contracts. And the decentralization is in a class by itself. In addition, it is developing a very large user community. If there are two weaknesses, it would be in its developer community, which is still very young and growing. There's thousands of projects being worked on, but it is not in the scale of an Ethereum community, for example. And the tokenomics of Algorand has been pointed at as a weakness. It has kept it, I think, out of the hype cycle, but it is a weakness, and it's something that Algorand has been addressing, and we'll talk about that. But overall, just incredible strengths that are now a reality for our community. So with the addition of Algorand, this is now a multi-chain ecosystem. And let's touch on just a few aspects of what now makes up the ecosystem. The GRN tokens currently held in individual Ethereum wallets and on exchanges remain on the Ethereum network. All GRN and GOV tokens in staking are now layer 1 assets on the Algorand network. All power tokens will be layer 1 assets on Algorand. There will be a bridge between the Ethereum and Algorand networks. And in the future, new chains for different purposes are likely to be added. This is more of a power chain network than just a power chain from this point forward. So how did Algorand solve the blockchain trilemma? Well, the source of its solution is in its name, Algorand, standing for algorithmic randomness. Algorand leverages mathematical randomness to solve one of the hardest problems in distributed systems: how to not only build a fast system, but one that is secured by an open and boundless set of validators. But what does that mean? And when we're talking about decentralization in blockchains, what are we really referring to? Well, in a low decentralized ratio, you're looking at a large user base and a small number of securers of that blockchain, and some of which are not even users of the blockchain. And this is something akin to what happens in Bitcoin, for example, where there's a small number of miners and they're securing the blockchain. But ideally, you want high decentralization, and that looks like this second diagram where you have a large user base and a large group of securers, most of whom are also users. But that's a very hard ideal to realize. So if the solution to the trilemma lies in mathematical randomness, a likely candidate for coming up with that solution is Silvio Micali, who is the founder of Algorand. Silvio has been a professor at MIT for nearly 40 years. And in that time, he's become a legend in the field of cryptography. In 2012, he won the Turing Award, which is commonly referred to as the Nobel Prize of Computing. He also is the co-inventor of zero-knowledge proofs back in 1985, which has become a fundamental building block of the entire cryptocurrency field and cryptography in general. So he just has a legendary status in that regard. It may seem that randomness would be something simple, but as it turns out, randomness is difficult. And yet it can be very useful. The ancient Greeks developed a device for publicly provable randomness called a clariterion. In ancient Athens, random selection was used for councils, state offices, and court juries. Random selection in this manner ushered in an age of democracy that lasted over 1,000 years. And it was all because they had a physical device that was able to provably be random and accepted by everyone as random. Now in the modern era, something that, once again, Silvio Micali was part of, an instrumental part of, is something called verifiable random functions. These are used in cryptography to create a virtual format of publicly provable randomness. This concept was first introduced by Silvio and two colleagues back in 1999, and they've become very useful in cryptography, and especially as we get more into privacy related to cryptocurrencies. The key is verifiable random functions using zero-knowledge proofs. So Silvio is very well suited for that. These VRFs are now widely used in cryptocurrencies, in the design of protocols, and in cybersecurity. They represent a major triumph in modern complexity theory, and this is ultimately the way that Algorand escapes the trilemma. Algorand's unorthodox approach to blockchain consensus is called pure proof of stake. They've introduced a process called cryptographic sortition that randomly selects a group of validators. So by a provably fair lottery, the protocol chooses 1,000 validators for each block proposal and each validation. Now the Algorand network breaks the confines of current norms by building a system of blockchain governance where the rulers are not a chosen few, but are the entire network. It's consensus for the network, by the network. And it's very akin to the ideal of self-government and direct democracy. Anyone can become a validator, and this is governed by the same cryptographic lottery that every token participates in on every round of validation. So this pure proof of stake is pure because sortition is open to anyone and everyone, and every token has the same probability of being selected for the lottery. How can sortition be both fast and secure? Well, it's fast because it takes only 1 microsecond for a wallet to figure out how many winning tickets it has and prove that to the network. And it's secure because no one can cheat the lottery. Algorand's design philosophy is that sortition takes a microsecond to participate and the age of the universe to destroy. Consensus is easy to reach and difficult to subvert. And the risk of chain forking has essentially been eliminated by this method. As it turns out, this property of not being able to fork is very useful in defending the network. And you can see that, of the 5 prime attack types that are the plague to blockchains, 2 of those, and 2 of the most kind of common, are defended against because of this forkless property. And the cryptographic sortition is also very instrumental in in other forms of attack. So overall, it is a system that is very robust and is well defended against these common attack vectors. Another very appealing characteristic of Algorand's blockchain is that it's carbon negative. So not even just carbon neutral, it is literally and verifiably carbon negative. The blockchain in general of pure proof of stake requires remarkably modest amounts of energy to run. In comparison, Bitcoin has been estimated to use 930 kilowatt hours per transaction. Ethereum is at 70 kilowatt hours, so significantly lower than Bitcoin. But look at Algorand's, that's 0.000008 kilowatt hours per transaction. It is ridiculously less than either Ethereum or Bitcoin. And they've gone that extra step of a company called Climate Trade has built on top of Algorand a blockchain-based notarization system for carbon credits. And Algorand has locked an amount of carbon credits that completely offsets its projected energy expenditures into a green treasury. So this is it's a notarized, verified confirmation of the fact that it is carbon negative. So that's a very attractive quality to our community, which, in our original blockchain, there was that same efficiency, or at least similar type of energy efficiency. So this is a great aspect of Algorand. Algorand is actually very developer friendly and is building up its developer community at a fast pace. The attraction is in the smart contracts, simpler to write and more secure. They do have an Algorand virtual machine now that's expanding the base capabilities and the composability. And there's also a heightened interoperability, so talking to other blockchains, that Algorand is really going to be a leading platform about that, given that a lot of layer 2 blockchains, like you'd see on a Polygon, for example, are leveraging zero knowledge proofs. And this is something that Algorand is, the inventor of that is the Algorand founder. And they've got a very strong system for attesting in these zero knowledge proofs, which are just passing information about the state of something without giving any information. So you're provably confirming that state, but you're not sharing the details of it. It'll prove to be extremely handy in things like identity, so self-sovereign identity in the future. You're going to be able to prove that someone is who they are without providing the details of their actual identity. And this is something that Algorand is taking a lead role in throughout the industry. These smart contract languages are also fairly basic. So they have something called Reach, which is a JavaScript-like language, and Python is one of the earlier languages for developers. So these are accessible to developers. They also have 4 different SDKs and very good developer support and documentation. So that's a strong element of something that could be considered a weakness of Algorand that they're rapidly turning into a strength. And this is indicative of Algorand's approach. They're very much about making continual improvements, and you see this with their continued delivery of new features. One is the contract-to-contract calls that are happening. This is allowing Adapt to efficiently and trustlessly interact with other smart contract-based dApps. And that's something so contracts talking to contracts is helping with automations. They're also heavily involved in post-quantum security. So they're generating their state proofs with a post-quantum secure Falcon key. And so this is allowing, Algorand is going to be not only providing other blockchains with proof states, but they're also going to be allowing the Algorand blockchain to be accessible in low power environments like a mobile phone or a smartwatch. And they're also working on increasing the capacity of their chain with something called pipeline consensus. So this is an optimization that will ultimately bring block speeds down below 1 second, and the transactions per second up to what is projected to be over 45,000 transactions per second. So they're looking to do that in the 2022-2023 timeframe. So it's a very, very sophisticated and talented development team behind the Algorand blockchain. So in summary, the blockchain trilemma has been solved. Algorand offers security, scalability, and decentralization. And the Powerchain now has both Ethereum and now Algorand. And the majority of GRN and GOV tokens and all of the Power tokens are now on Algorand. The remainder of GRN and GOV tokens remain on Ethereum. And there is a bridge that will be operating between these two networks. Algorand's new paradigm is compelling for both today's use cases and use cases in the future. It offers 1,000 transactions per second, less than 5-second finality, less than 1 cent per transaction, true decentralization, a smarter contract architecture, fast growing ecosystem, and very importantly, over 2 years of uninterrupted operation. So it truly is a new era, and we now have an outstanding foundation on which to build the future of our ecosystem.